Alright, back in the lab here. Now we're going to configure OSPF version 2 for IPv4. In this topology, we have two areas between our R1, R2, R3, and R4 routers. We'll start off by configuring our base OSPF configuration with our router IDs, define our network statements to enable OSPF on the interfaces that we want to, and then we'll advertise the connected routes on R2 and R3. Alright, let's get started with R1. Alright, so first we're going to say router OSPF, and then if I do question mark, we can pick a process ID, not to be confused with an autonomous system like an EIGRP. This value is a local value, meaning that it can be different between the OSPF routers. It does not have to match with our other OSPF neighbors. So we're going to just pick one, passive default, make all of our interfaces not participate in OSPF by default. Then our network statements. Just like we did in EIGRP with our wildcard mask, except this time we have to add our OSPF area. So if we look at our diagram, all of our ones interfaces are going to be a part of area 0. When we enable those interfaces, we'll just say area 0, and that will say enable this network for OSPF within area 0, our backbone area. Hit enter. We'll do the same for F10 interface. And now if we run show IP OSPF interface brief, we see we have two OSPF interfaces, process ID 1 and area 0. We'll say no passive interface F00 and F1/0. Almost forgot our router ID. Let's take a look at our configuration. And there you go. We have OSPF1, router ID 1.1.1.1. We enable these interfaces for OSPF, and then these networks for area 0. Let's steal this and make a script out of it. And then we can recycle this for our other router configurations. 2, 3. Now, one thing different on R2 is that besides its F00 interface, it's actually participating in area 1. So we got to make sure to change our area value to 1 there. Then it has the 10.2 network we're going to advertise, so 10.2.0.0. And now we'll have OSPF enabled on these two interfaces. So it will, since it has no passive for those interfaces, it will try to form OSPF peerings on those networks, and then we're just advertising this network but not trying to form a peering on it since it doesn't have a no passive command for that interface. Paste in our config on R2. There we go. Now we have 3 interfaces because we also have that 10.network, which is just a loopback in our lab here, and you can see that those interfaces are part of area 1. Okay, so that looks good. Let's modify our script for R3. Alright, there we go. Alright, let's do R4, and then we'll start looking at the routes we're learning as well as our OSPF neighbors. R4 has both interfaces in area 1, so 3 network and the 4 network. Let's paste that in. Alright, so now that we have OSPF configured on our interfaces, let's run the command show IP OSPF neighbor. We see that R4 has 2 neighbor adjacencies just like we wanted, one with R2 and one with R3. Let's run show IP route OSPF, and we have multiple OSPF routes in our routing table. This O code here stands for intra-area OSPF routes, meaning that the routes were generated from a local area. So those would be Area 1 routes, since R4 is in Area 1. And then these OIA codes mean that these are inter-area OSPF routes, meaning that they were originated from a area outside of this router's adjacencies, meaning Area 0. We can also run show IP OSPF database. This is our link state database. We can see all the different LSA types that we've learned in this topology. Alright, next we're going to advertise default routes from R1 to the rest of the topology. And then once we verify that R4 learns these default routes, we're going to modify its interface cost to make the path via R2 the preferred path, to show you how we can change which OSPF routes are preferred based on our cost value. Alright, so we're in R1. We already have a static default route, so all we have to do is go under our OSPF process 1 configuration, and with OSPF we're going to say default-information originate, and that's going to advertise a default route if we have one in a routing table. You can also use the always keyword to say always advertise a default route even if we don't have one in our routing table. But for here we're just going to say default-information originate. If we look at R4 now, we see that it's learning 2 OSPF default routes. And you see this E2 code here. That means that it's an externally learned OSPF route. So perfect. So now let's look at show IP OSPF database. And we see we have this type 5 LSA coming from R1. That's equal cost, so we installed both of them in our routing table. Now let's go to R4's F10 interface, and we're going to make the cost higher than the F00 interface so that the OSPF metric is worse, and it will remove the route via R3 and only have the preferred route to R2. Before we change the cost, let's look at the existing OSPF cost. I goofed there. It's actually show IP OSPF interface and then F1/0, and we see that our current cost is 1. So let's make it, to change the OSPF cost on an interface to manipulate our routing metric, we can say IP OSPF cost and then a value between 1 and 65,535. We're just going to say 10. Let's run show IP OSPF interface again to make sure that it took it. And now we see that interface has a cost of 10. Let's run show IP route again. And you can see now we only have one default route installed on our routing table, and it's via R2, just like we wanted. Next, we're going to look at how we can configure and verify our OSPF DR and BDR routers. If we look on R4 right now, we can see that it is the DR since it has the higher router ID when compared to R2 and R3. So just to show you how you can change which routers are the DR, we'll go to R2 here, and we're going to configure the interface that's on the R4 segment with a higher OSPF priority than the default of 1. Now you can see that it still hasn't taken the role of the DR. Well, we need to clear the OSPF process, which is something you have to do sometimes when you make certain changes. So we'll say clear IP OSPF process, hit enter, and then we have to confirm that we want to clear them. And now we can see that R4 is the BDR. And if we look at the R2 show IP OSPF interface, F10 with a higher priority of 10 now, it is now the DR.